soon the merchant found himself in a torture chamber underground. Tied and bound, he sighed and frowned. And so they tortured him for night and day. They made him scream so much his hair turned gray. But as for the recipe, he would not say. They could not flay his pride away. He lived alone, and every night he sat upon a throne of pumpkin pie. I do not know his name. They say his name. He never wanted all the pain that came with pumpkin pie.
Hi, everybody. I'm not going to tell you about pumpkin pie in particular today. I'm going to tell you about Pi, which is a game development DSL for making simple games. My name is Sarah Allen. I lead a small band of consultants in San Francisco that go by the name Blazing Cloud. I also have a small yet mighty startup, Mightyverse, and I am president of Rails Bridge, and I lead the Teaching Kids project there. Aside from these organizations that I'm affiliated with, doing something we sometimes call work, my most important job is as mom, and I am CIO of my family. And as a mother, I find that the American school systems don't teach everything that I think is important. I believe that children should learn a foreign language, that it's important to experience other cultures, and that children should learn how to code. Now, this is not just because, it's not even relevant whether they're going to travel to another country. It's not even relevant whether they're going to grow up to be a programmer. What's relevant, first and foremost, I think, is that kids expand their brains and just get exposed to as many things as we as parents and educators can show them and teach them. But in particular about software is I feel that in today's world, so much of software is about how our world works. You know, how our phones work, how our televisions work, how our cars work. It's like teaching kids about photosynthesis or genetics or mechanics or physics, right? It's not that they're going to grow up to be physicists necessarily, but kids should just know what's going on in the world, and what we know about we should pass on to them. So I started this project about a year and a half ago. It didn't go by this name. It was more of an idea around middle school curriculum. And I noodled around with this idea of teaching web-based games for a while. And then got busy this past year, and it didn't quite develop into a curriculum, but it was important for my main inspiration, my son. And he agreed with me after, we did a bunch of programming experiments in the spring. He agreed that he was going to pair program a game with me. And in August, he told me that he'd do this right before I left on a trip for Japan. He said he would do this if we could make it work on Android. So this was my mission as I was heading off to a trip to figure out what I was going to build and build with him. So the key thing in thinking about this is to make programming fun, right? I wanted to not just expand his brain and teach him about the world, but I wanted him to capture some of the excitement that I feel when I program. And I brainstormed with a bunch of friends and basically came to the conclusion that it's important to have immediate gratification. It's important to write just a little bit of code and have a big effect. And so at first I was thinking, well, maybe I'll make a library that we can use. So I do some of the hard parts, right, so we can just stitch this thing in. And then I saw this talk at RubyConf by Yasuko Oba about writing a DSL. And I thought, that's what I can do. I can make a really simple language that captures these fundamentals, and that would allow us to very quickly and easily make this game. One of my son's favorite words is pie. It's really fun to say, aside from being a yummy food. So I decided to name it Pi, and it's around this idea for a game that we had brainstormed. We've only really built half of it. But what I'm going to talk to you now is a little bit about what is Pi. I've already told you a little bit about why I made it. And then I'm going to give you a primer of metaprogramming, basically the key concepts, the key Ruby syntax that I used in the development of Pi. And then talk about the language design. How did I come up with the syntax? What was my process for that? And that's what this talk is about. So first, what is Pi? It's a simple language for simple games. If you can read the fine print, Pi has 3 repositories. It's on GitHub under Blazing Cloud. There's a gem if you want to run it on your local machine, gem install Pi. There's a hosted IDE that's written in Rails with a little Sinatra, which is the Pi Bakery. And then if you want to run it on your mobile phone, you can get the mobile Pi repository and say rake run iPhone or rake run Android. It relies on the Rhodes gem, and it'll run on the phone. If it's too simple and you want more, what do? You just write some code, because it's Ruby. It's an internal DSL. So this is what Pi looks like. It's a simple web game. You've got an image. You've got a description. In fact, I'm going to show you one right now that the kids made upstairs. So I was going to show you my simple game, but this is a fun game that the kids made in about an hour, a pair of them. So you're on an African plain. You see a zebra and a lion. Do you want to go to the zebra or go to the lion? Okay, we're going to go to the zebra. Oh dear, you were eaten by a zebra. So we'll restart. Do you want to go to the zebra or the lion? Okay, we're going to go to the lion. You are now part of the lion pride. Congratulations. Shall we hunt the zebra with the pack? The lions and you are eaten by the zebra. Oh dear, you're dead. So even in its simplicity, it can still be entertaining. So it also runs on Android and iPhone, presumably on BlackBerry and Windows Mobile, but these are the only phones I've tried it on. Technical notes, the basic application was originally, the web app runs as a Sinatra app. You can learn more about Sinatra at sinatrarb.com. I recommend it. It's a lot of fun. The mobile apps run using the Rhodes framework by RoMobile. You can learn more about that at romobile.com. And the hosted IDE runs in Rails. You've probably heard of that. And I think I showed you all of its source code. So that's a little bit about what is Pi and why. Now I'm going to talk to you about how it's made. So metaprogramming. So we use metaprogramming in order to create a DSL. This is one of Yasuka's slides that I borrowed to explain that there are really 2 types of DSLs, right? There's an external DSL, like, where you're writing a domain-specific language, and you're writing it in another language, and you might be writing a file that you're reading in a language that's different from the language that the DSL is supposed to express. And then there are internal DSLs, and there are a lot of those in Ruby, like rake, like Rails, which is written in the language that it is also parsed in. And that's really handy because you can just break out to that language at any time. Since one of my goals was to get kids writing real programming language, I thought an internal DSL was a really good choice. So the Ruby techniques that I used in Pi are just a couple of different ones. One, I use the Ruby 1.9 hash syntax. I use method missing, and then I evaluate blocks with instance eval. So first, for those of you who's using Ruby 1.9, woohoo! So most of you already know this, but in Ruby 1.9 you can use colons instead of hash rockets. When teaching kids, I found that the hash rocket was sort of hard for them to type. The colon thing equal, and there's just a lot of typing there with special characters. It was complicated. So I thought this is going to make it easier. Method missing, you probably all know about, but this is the easy way to make sort of a declarative syntax. And this is how we declare our places. And then you can create these blocks that seem like declarative code. So we've got this like make pi do expression, which is implemented, as you can see on the bottom, where the blocks passed in, and then the pi.new, so pi is the class, pi.new creates an instance of that class, and then we call instance eval on the new pi instance. We pass in the block, and so then the context for the block will be that instance, so that when whatever happens inside there will be called on the pi instance. So this is really handy because you can sort of gradually introduce programming-like stuff. And then the other trick that we did was to just remove that altogether and sort of make this invisible context by loading the pi script in a file and then just evaling it in the middle of an instance eval. So that's nice because then, some of the boilerplate disappears. So those are the specific, sort of Ruby syntax. The only thing that I really had to learn was instance eval in going into this expedition. So, on to my case study. First, I want to talk about the learning process. What I did is first imagine what I wanted. What kind of thing am I wanting to express? What's the kind of syntax that I want? Then I just made it work. Like, do what I know, actually make the end result that I want. Then I took that code, refactor it to create the syntax that I wanted, and then I could actually have a system that worked. Then the big test, of course, somebody who's not me uses it, and they think, wait, this doesn't work the way I expect. And so you improve the syntax, rewrite the code, and do that over and over again in quick iteration, or slow, depending on how much free time you have at that week. So this process worked really well for me, and I'll go through exactly how the syntax evolved. So first, step one, imagine. So this is my imaginary world. I've got a cave, a cliff, and a forest in this world. If I go out of the cave, I get to the forest. From the forest, I can enter the cave, or I can go west to the cliff. I can go east from the cliff to the forest. If I go east from the cliff, I die. And that's my whole world. So this is the kind of thing that I wanted to express in this DSL. So then I thought, okay, I want my places to be declarative. So I figured I'd put them in this create places block, and that would scope all of my places nicely, and that for every place I'd have a description. So I have my cave, you're in a big cave, forest, the forest is very dark, and there's a sheer cliff at the cliff. And then every place can connect to one or more other places, or zero or more other places. So then I thought, okay, well, I could have a hash of all the paths outgoing, whatever that place connects to. So, and then the other thing, I didn't tell you about this, but the other half of pi that hasn't been implemented is there was this idea, the part of the game idea is that there's a character who, when they go to a place, they might evolve into another type. So then I said, okay, we'll have a create player block, and then we'll evolve, and you're an egg when you're in the forest, and then if you go to the cave, you become a rabbit. If you don't go to the cave, you don't become a rabbit. And I imagined that we might have syntax like this. And then I wanted to declare all of the images. I thought we could just sort of couple them with the place names, and then you'd have to say that it started. So that was my first idea of what the script might look like. And there it is all together that you probably can't read, but just to give you a sense of it. So what I did then, and I think that this is really helpful for me in development, is I pulled it down into the most simple use case I can imagine. I said, okay, I'm going to create a book. I'm there in Japan, I'm learning Japanese, feeling like I'm a 3-year-old because I can say things like, big ship. So I thought this reminded me of when my son was 3 and we had books like that. So I thought, I'll make a book that says, Ukina Fune, and other things that I'm probably mispronouncing. So, so I have my places, I have a ship, a building, and a tower, and that I figured we can just order them. The first one's first, they automatically go next, and this would be really, the simplest syntax to implement. So then the next task was to make it work. So what I did was I wrote this, which doesn't look at all like my destination, but it was using the syntax that I really was comfortable with at the time. I could do, so this has a set of places. I realized I wanted to have a title page and my images. And then it calls start. And this actually worked. This was a Sinatra web app that worked. So this used a little bit of declarative code by declaring a class method. So this is the simplest way to do that. It's a pretty common trick. And I just have a name of my place and a description. So that, not a very fancy DSL, but that's what I did. So I had the thing, it worked, I ended up, and it took me kind of much longer than I expected, and I learned a lot in the making of this thing. Like at this point, I had the output that I wanted, and that was a really important step. Then I refactored it quite a bit, and I ended up with something that looked like what I wanted it to look like. And here's the tricks I used. So I created a global method, make pi, which took a block. I ended up having to make this pi global instance, which I wasn't really excited about, but I couldn't quite quickly figure out how I make the pi script communicate with my Sinatra app. But it ended up with the script that I wanted, so that was a good step. And then again, I instance eval the block, and I end up with the make pi do that I was interested in. Then I had this create places. I ended up making a place class that was scoped inside the pi class. And then I created places in that scope, which actually worked really well because without having that scope, it would, method missing would get called, and I'd get these weird errors, and they'd be sort of arbitrary. So it was really helpful to have the method missing be on this place object and have it called that according to that scope. So, so that's how I got to there. Then I needed to make the paths to link up my places. So, and actually this is, in truth, I had these 2 things at the top. I had to require the pi library as well. So, so then I added places. It turned out that I had to have, because I had a book and a game and they ended up looking different, I ended up having a template. So I had my template for my game and template for my book. And then I ended up calling them links. So we could have links, like if you're in the park, it would have links that the trees were to the north and the river edge was to the east, and so forth. Then I got my first user, and she said, that's kind of weird. I think we can do this more simply. If you look at these, she was a little frustrated because every path, the way the trees were connected to the park were, the way you think about them, one thing. Even though there's one label north that goes to the trees and then south that goes to the park, it's one path. So we came up with this new syntax where we just define the paths. It's not that much, more or less code, but it sort of fit logically how you think about this directed graph pattern. And then there had to be a way to have something end, so I just created this no way back constant, which seemed to work. So now I had something where you created places, you created paths, and this sort of matched the way that people, or at least we imagined people would make these things. And it turned out that people would sort of think about all the places and then think about how they're connected. So then I showed it to Caleb, who looked at it and said, no, I don't know about this path thing. If you look at this, it's a little ambiguous. Does this mean that if you're in the park and you go north, you're at the trees? Or does this mean that the park is to the north of the trees? And I found myself having to sort of repeat this mantra, park, go north to trees, go south to park. And you know when you're having to like remind yourself of something that it's wrong. So the other insight he had is that, oh, well, you've got this map-like thing. Well, maybe you should just have an object that if it's like a north object that knows that the reverse direction is south. So he pointed out that this is confusing, and most of the time you have these reciprocal directions and it's redundant. So we came up with a syntax that if you go, we'd have a park object that if you take a path, we'd go, we could say what paths go from that, and then they'd automatically reciprocate. And then there was the issue of, well, how do you specify that if you go east into the river and you drown, that you can't go back? And so we changed this to be East Bang. So we thought that would be like a little Ruby teaching. Final or destructive, or however you want to call that naming convention. So then we ended up turning these 3 lines in, not only just 3 lines into 2, but 2 more meaningful lines, 2 lines that were more expressive. And so I was pretty pleased with that, but we did all of this in, just our imaginations, and then before I had a chance to change it, I went to Golden Gate Ruby Conference and ran into another Rubyist who was experienced with writing domain-specific languages. And Rich said, wait a second, I think we could make this a little simpler. If you take all of this, you don't need all that code. And this was a nice insight where there were some problems we solved, and we ended up taking what was originally 23 lines of code and implementing it so that it could be 13 lines of code. And we solved the scoping issue by just saying, okay, you declare your place, you declare your image, which also has a nice side effect that if you wanted to, you could interleave these things. Like you don't, the order doesn't matter so much. You don't have to clump all your places together. So, so in summary, and I've done this talk quickly to make sure that we had time for questions and discussion, because I think that'll be interesting. It's really important to have many eyes early. You need to cherish your early users. It's the time that you have 1 or 2 or 3 users is fabulous and wonderful, and you should listen to them and do everything that they ask, because that is the time before you have to worry about backwards compatibility. You don't have to, do all of the fancy things that, I sat in a track yesterday and heard about maintaining code. You can just rewrite your code all you want. Rewrite often when it's early, but also keep real uses in mind. It's great to start with that simple case, but then think about, always keep your vision about like where this is all headed. The other thing that's really important when developing a language is that errors are part of the user experience. It's really easy to fall into this trap where if somebody runs into an error, you just fix it for them or tell them how to fix it. And then later you think, how do I make, now I have this bug in my list, which is make errors more usable. And then at that moment, there is no way you can reproduce that error. So, so it's always great to save off the scripts that fail horribly and then think about good ways to say them. So I want to end with next steps. So error messages are still strange, even though kids are actually able to use this little language. So far, nobody's used it unassisted, not that I've really recruited folks to. The mobile app creation is awkward. You really have to like sort of copy files around. and know an awful lot to set up the project for the mobile app, and it could be a push-button experience, which I think would be really, really fun for kids. And I think that despite the fact that, these kids came up with a really fun game today, I think it's really still too simple to be a truly engaging experience. So I look forward to having a few more features. So I want to open it up to questions and discussion, because I wanted to leave enough time to not only answer your questions about Pi and about my experience in developing Pi, but if anybody has questions about teaching kids programming or stories to share about that, I'd love to talk about that. Yes? That's a good question. So the question was about how kids iterated and how it got to the server and how it got to the phone. So that's a great question. So first off, when the first two kids were using it, it was a Sinatra app that they could run locally. So, so they would just do Ruby Pi, their game.rb, and it would just run the app. And that worked really well. They could get that. They would run the server and go back and forth. I tried to get the kids to deploy on Heroku, and even though that's like 3 steps, it was kind of too steep. So what I ended up doing, actually Sarah May and I did this originally for Mountain RB. We have the Pi, if you go to pi-bakery.heroku.com, you can click Make a Game, and what we use today is this this sort of hosted IDE. So it's a Rails app that's not test-driven at all. It's like a scaffolded thing that was the product of crazy drunken coding experience. So here we are. You could say like here you are on an African plain. Let's make this much more different. Here you are on Mars. Okay? So then we say update game, and it says here you are on Mars. So that's the kind of iteration that kids want. And the other thing, of course, we learned this morning, which I have to learn like every time I do anything with kids, is that installation is really boring. We did some Ruby processing in the morning, and it was really hard because we had to set up their machines. And then we did Pi in the afternoon, and it was awesome because they just went to a web browser. And so I haven't had the kids build to the mobile device. Yes. Great question. So the question was about teaching your own kids and about the age level at which you teach. So I believe that it's important to, especially when, it's much, much easier to teach other people's kids because you have way more credibility. When you teach your own kids, it's like, yeah, but I don't believe you, Mom. You're not really good at this. Or whatever, or it's not really fun. But so my best experience was I actually talked to my, when I first taught programming in a 4th, 5th grade class, and I talked with a teacher about coming into my son's class, and I taught 3 sessions on shoes. And that worked really well because then I'm the cool mom who comes in and makes them not have to do math class. Right? So that works really well, especially elementary school kids. Like elementary school kids want, most of the time, if you can get, so you're the cool activity, they don't mind you coming into school, right? Like by the time you get into like middle and high school, like your kids don't want you in school, as I'm sure you've experienced. I don't know, maybe your kids want you in school. So anyhow, so I did sort of programming-like stuff younger than 4th grade, but it didn't work very well. The things that worked really, really well at the younger grades were time-lapse animation. So like doing things with computers as tools. So I think that those kinds of things that are like making stuff with digital cameras and understanding like how to use the tools is great in 1st, 2nd, 3rd grade. So I think 4th, 5th grade is a great sweet spot because kids don't have a lot of biases then. They still think that, that you can like break their naivete a little bit, you know. I taught a group of kids who half of them were born before, what was it? Half of them were born after Google and half of them were born before Google. So that was like, and they had not thought about the fact that there was a time in recent memory before YouTube, right? Like for them, there was like Einstein, the invention of the telephone, the invention of the television, the invention of the internet, the invention of YouTube, and then like their grandparents were born, right? Like they have no idea of the concept of time and history. So it's great to like sort of introduce them to some of these concepts and, you know, and so in 4th and 5th grade we did like RGB color and that was really fun with lights. But I think that somebody told me that when you're 12 years old is when you start learning abstract math becomes easy. That's the reason they teach a lot of algebra when you're 12. So I think like 11 to 13 is the sweet spot for teaching programming. And the other thing I would just give advice to in teaching your own kids is to just expose them to stuff and see where it goes, right? The last thing you want to do, and I'm on the edge of like going too far here, is like get more into it than your kid is, and then they're like, it turns them off, right? So you've got to, because as soon as it becomes your thing and not their thing, then it's a whole different ball game, right? They're not really learning it for themselves. You're not teaching them, you're putting something on them. So you just got to put it out there and see if they come to it, and then if it doesn't work, try something else, right? And so one of the reasons I did a web game is because I realized when I taught them shoes, I thought it was amazing that in just this amount of code you get a desktop app. Kids these days, desktop apps, they use for their homework. Web apps, they use for games. So it's like, you just have to be able to recognize when something isn't working and try something else. Other questions? In the back there? Yeah, they have. Well, so the question was, do they ask what it was built and how they can modify it, and I'd like it to do this. So they have, so far, nobody's asked me, how was this made? In any of my teaching experiences, they have like zero curiosity. They just expect that everything is there for them, which is probably goes both good and bad. The other, so they don't even think about, I could modify that. It seems like too steep a learning curve. Right? This is just mystery, right? This is just as mysterious as what's inside their phone. So do they ever ask for more stuff? Yeah, they're like, oh, wow, can I make like a wizard who can like spin around and like shoot things? And then I'm like, well, let's start with a character who's just an image. I'll work on that. So. They think that like the machine can do anything, but that it's inaccessible to them. So that's what I'm hoping that we can sort of bridge a little bit, take those barriers down. There was another question. In the gray? I think that, I don't think there are enough kids who know each other that are playing with this for it to have that effect yet. So the question was about social games and how much they learn from each other. So it's funny because there are all these games on there that do different things, but when they wanted to, I have this, if you go to this piebakery.com, whatever. So it's got this little cheat sheet here, right? Which just shows you how to go north and east, or east with a dead end. And they wanted to say, go to zebra, go to lion. And so they didn't say, oh, I'm going to go look at another game that does that. They said, you should fix the documentation. So I think the trick is the games have to be a lot more compelling, that they're really playable. And then if they play them, they'll be familiar with them, and then they would look to the games. But otherwise, they want it to be right there for them. So I think that's the challenge, is how do we make them like actually more fun? Other questions? So the question is, do the kids, one kid who's ahead ever help the other kids out? And so absolutely. And that, in fact, they love showing off, their expertise. And I think that the more that as teachers we can encourage that, the better, because then instead of the kid who's being really fast is frustrated, then they become the expert in the class. And by helping other kids, they get to debug some of the more challenging problems, which then it's not just a social experience for them, it actually sharpens their technical expertise, which I think is a really good thing that happens naturally, I've found. In the back corner. So the question was, for the kids who have a real passion and aptitude, what do I recommend for them? So it's really like, I just kind of make that stuff up on the spot, generally. There's a lot of resources for kids, but there aren't a lot of pointers that don't require a lot of reading. I think one of the things that's challenging, at least since I learned to code, is like it used to be that it was much, much more accessible. There were fewer things that you could do, and the computer was much more raw. To date myself, I started programming on Apple II. You booted up the Apple II, you could like type in BASIC, right? So now you need all of these tools, and you have all of these decisions about, am I going to do this or that or the other thing, and that can be really overwhelming to kids. So one thing that I recommend is, which I think is fabulous, is the Chris Pine book for kids who are really, really motivated. That book works really well. But they have to be of an age where reading isn't a big issue for them. So kids who are really into this stuff, who aren't yet of an age where they're good readers, it's challenging, and I think that it helps for them to be sort of adult assisted and to have an environment set up for them that then they can play in. So the question was about high school kids. I know Ruby Newbie is working on a program that involves Rails, which I think is really exciting. I think there's a lot of things that can be done with high school kids. And one of the things that, if I had all the time in the world, I think it would be straightforward to set up a program where the high school kids help the middle school kids, and then the middle school kids become the high school kids who help the middle school kids, and then it would just perpetuate itself forever, and it wouldn't take that much. Like, you could have, it kills me that, at least in San Francisco, of all places, all the school computers are Windows machines, which means that there's like no self-help, and they're all locked down, so they can only be fixed by like the one guy in the whole school system who comes out 2 times a year, right? Like, we could be running Linux, we could teach the high school kids to fix the Linux boxes, and we would be spending like a tenth of what we spend on computing resources, and we could put the other money towards teachers and resource people and all sorts of things. So I think there's an enormous amount that can be done, but there are just very few people involved in the school systems, you know, who are making it happen. And I think that the schools are trying really hard, but it's really challenging for them because they're not technologists. Second row? Yes, San Francisco. Summer Bridge? Is it a school system thing? Cool. So that's Summer Bridge. I'll have to check that out. So it's this is Summer Bridge. It's a summer program, and that has limited. So there's a limited number of kids who can go, but that it's been effective for the ones who've been involved. And that's it, where in the Bay Area is that? So, all right, I'll have to look into it. How are we doing on time? I think it's about time for the break. Thank you. You've been a lovely audience. I appreciate the conversation, and feel free to come on.